All right, ladies and gentlemen, so let's take a look here at this very interesting problem. And of course, the focus of this video is going to be a continued application of our inscribed angles theorem and just in general about polygons inscribed in a circle. Just to kind of recap, if you're kind of just catching in on this video, we've been discussing our inscribed right triangles theorem and our inscribed quadrilaterals theorem. And then we've also already covered our inscribed angles of a circle theorem as well. So let's think about how we can kind of use that in a little bit of mathematical application. And again, I really challenge you, pause the video and see if you have kind of any ideas as to how to go about this problem before we kind of reveal it. So it says your camera has a 90-degree field of vision and you want to photograph the front of the statue. So you want to keep our front of the statue in sight. You stand at a location in which the front of the statue is all that appears in your camera's field of vision as shown. So you down here, you've already taken your shot and it's perfectly in vision. But you want to change your location. So where else can you stand so that the front of the statue is all that appears in your field of vision? Well, if you kind of just think about common sense wise, I mean, as you get closer to the edge on over here, if you just follow this straight path, if you've ever taken a picture in your life, you can kind of realize what ends up happening is that partial of it starts not being in the picture anymore, or you have it at such an angle where then all of a sudden you don't really see the front of this whole right side of the statue. And same thing goes if you go to the left on over here. And so we have to kind of think of how can we use some geometric concepts to continue and make sure that in fact it's going to stay in that line of sight. So I have my compass here. What I want to do is I want to try to draw a circle that's going to hit these 3 points to the best of my ability. So hopefully it'll kind of come on over, and not perfect, but not bad either. So we were able to kind of make a little circle here for our little guy. So let's what are some options? Well, let's really think about what is created. Think about our right triangles being inscribed in a circle. If you remember correctly, the only way that we can inscribe, and right now I know I'm off a little bit, but if you can kind of imagine that's there as well, if you can imagine that this is inscribed in a circle, remember the only way that this actually happens is if the hypotenuse was what? The hypotenuse had to have been the diameter of the circle. The hypotenuse had to have been the diameter of the circle. So that's green. We're going to say that this right now is our diameter. Okay, so the green is our diameter of the circle. And so if we continue to kind of think about another inscribed right triangle, what if I just put a point, let's kind of keep the theme, what if I put another yellow point just right here, and this is where we went ahead and just went. Well, if this was going to be a right angle right here, what if connected a line right through there into here? The only way that I keep the same vision is if it's going to also be a right angle. Because the only way this is a right angle in a right triangle created in my inscribed semicircle right in here, and the only way this happens is the diameter is the hypotenuse of the right triangle. And same thing kind of goes on over here. Let's just kind of test it out over here as well too, just for some visual representation. I'll get a different color for you, I guess, to kind of show it as well. All right, so if we kind of take this point right here, and I connect it on over here, and I inscribe that other point right over there, the only way that this is a right triangle is if that diameter is still the hypotenuse. So it didn't really matter. Wherever we went on our circle, I could make points everywhere. I can make points all over this circle. And the only way that I'm going to keep that 90-degree vision is if it's an inscribed right triangle. So it really didn't matter. I could go anywhere on this circle with these specific points and still keep my 90-degree field of vision for my camera. So I thought that was kind of an interesting kind of food for thought type question, really focusing on application of some of our theorems. On to the next one.